What if you want to make your own non-standard segments? At the beginning I decided to use 2mm thick steel sheet. It's going to be a frame, allowing to attach everything and hide the electronics. Speaking electronics, it was reused from my previous project. The front was made of 4mm glass with a passepartout made of UV paint. It's slightly transparent, so in the future I would use ceramic. The PCB was designed in the shape of a segment. There are so many LEDs because I don't know how many will be needed and always can leave them empty. The frame of the segment was 3D printed out of a PLA and attached with a superglue. I found that clamping PCB to a shell in a vise was the best to keep the process fast and prevent the epoxy from leaking. It's got self-leveling properties, so it needs to stay flat during curing. After ordering first 30 PCBs, I made a research. Unfortunately, I made a mistake and didn't predict how to screw it after resin cures. My first attempt at fixing was to insert pneumatic tubes in the hope of removing them later, but it's just impossible to rip anything from epoxy. So in the final version I screwed that to the spacer before filling. Resin with a transparent greenish pigment is a bad idea, no matter the amount of LEDs. These are 4 independent layers of epoxy, there is nothing to scatter the light. These are red LEDs, the first layer is transparent and the other 3 contain dye called pearl white. This was my best result, despite a corner being slightly dim. This is transparent, followed by white, transparent and white again. These are 2 transparent layers and 2 white in a row. This is a single transparent and single white with a thickness of 3. This is a single transparent layer and 4 white. These are white LEDs, followed by 2 transparent layers and yellow. Gives better luminosity than just yellow pigment. Looks greenish, I know. Same as before, red on top. Same again, just green transparent on top. These 3 sets are transparent layers followed by 3 white LEDs are green, yellow and blue. On this it's clearly visible that layer thickness does matter. Red LEDs, single transparent and single thick white layer, and 4, 8 and 10 diodes. White LEDs with transparent and yellow. Same as before, just red. White LEDs transparent, white. In this attempt I try to pour the resin from one side. It's really good. Here I disassembled ordinary aquarium pump and use that to mix pigment with vibrations. This is using a hot air gun and mixing from above. This is heating from underneath and more dye than usual. It barely shines through. This is using respectively 2, 3, 4 and 5 spatulas of pigment. Conclusions. The first layer needs to be transparent in order to conduct light. The amount of pigment matters. Vibration mixing helps disperse light evenly. Layer thickness matters. After all of that, I decided to go with 14 LEDs, a single transparent layer and a single colored one. Green was made by adding green transparent dye to white. Looks dim due to 100 mA of current consumption in total. This is a comparison of a segment of 20 mA per LED.